Hi, this project is presented by Group 18, Advanced Robotics in Manufacturing, which is the overview of robotics in manufacturing. This is presented by Satman Sadar,
Jesse Rada,
and Mohammed Rahman.
The first part of the introduction of robotics manufacturing will cover the background. The origins of robotic manufacturing came from an increase of minimum wage. This as a result caused the price of labor to increase and the price of production to increase. Companies needed a way to replace cheap laborers in the workplace. This led to an invention of the first industrial robot, the Unimate. This robot was first used by General Motors in 1954. It is noted that these robots were very limited in their capabilities. The second part of the introduction of robotics will explain the importance of these robotics today. Robotics now play a very important part in manufacturing. It is expected by 2019 that the robot manufacturing industry will be worth $135 billion. By eliminating human error, robotics have increased part quality by increasing accuracy and repeatability of the manufacturing processes. They also reduce scrap percentage by reducing error in the processes they perform. The cost of labor is also reduced as less workers are needed, as well as products can be made quicker as a result of automation. Furthermore, the products can be tracked better as the industry becomes dominated by computers. The next part of this presentation will take a look at state-of-the-art robotics. Companies continue to want more robotic automation in their industry. They want robots that are more versatile, capable of performing as many tasks as possible. Making machines that are universal may help lower the cost of these robots. As well as making more types of robots, more labor jobs can be replaced, further reducing the cost of production. Some new robots that have been seen to be improved and will be covered in this presentation are AGVs and robotic arms. An important robot in the manufacturing industry are AGVs. AGVs, or automatic guided vehicles, are robotic vehicles used to transport materials and products around factories and warehouses. They are important as they are more reliable. They have less of a chance to be late for their material delivery as opposed to their human counterpart. Some of the advances in the robotic section have increased technologies in their sensors. AGVs now have visual sensors and computers that can make 3D maps of a building and plan out the most efficient track. These sensors also enable the robot to see foreign objects such as workers or drop products and react accordingly. Assembly robotics is another major section in the robotic manufacturing industry. Assembly robotics usually consist of robotic arms. These are the first type of robotics to be used in the manufacturing industry. They perform simple tasks such as moving parts a short distance, relocating parts, and holding parts in place while another robot performs a task on them. They are very important as they can precisely lay parts for robotic welders to perform their task well.
Arc welding robot. Robot arc welding is the utilization of mechanical programmable devices, which totally computerize a welding procedure by both playing out the weld and holding the part in place. Robot welding is normally utilized for resistance spot welding, splash painting, and arc welding in high production applications. According to the International Federation of Robotics, 50% of all the world robots are used for welding. Majority of the high-end robots at present utilize AC servo motors because they are basically maintenance-free. Because of this, AC servo motors have replaced the traditionally used hydraulic actuators and DC servo motors. An arc welding robot system has a torch linked to the wrist of the robot, which is capable of 3 axes of motion. This helps the torch to reach difficult angles, which is required for complicated 3-dimensional welding. Moreover, robotic welding is safer, cost and time efficient compared to manual welding.
The future. Robots in the manufacturing sector, which are designed to perform operations in a quick, continuous, and accurate manner, and in large numbers, have a long heritage in work environments. The rapid growth of these technologies raises serious concerns among engineers about how to adapt to building modern manufacturing systems. A framework is needed to incorporate automation and robotics, which will allow the implementation of more advanced manufacturing design strategies and maintain advanced manufacturing systems. Aspects like Functional hierarchy, strategies to predict the future, and possible outcomes are discussed in this presentation. Functional hierarchy is a productivity maximizing tool that is developed by SRI International, which shows programs that can be combined into numerous ways to make workstations and cells, automation systems, and robotics with varying measures of effectiveness. The modular approach shown can be upgraded by adding programs or replace programs with improvised versions. As manufacturing systems evolve over time, new types of programs can be used to provide new operation. The arrangement in an orderly manner together with modularization of hardware for the human-machine interfaces, robotic devices, and workstations improve the capabilities with time with minimum impact on manufacturing operations. Now I'm going to talk about strategies to predict the future. The manufacturing system can best be considered as a multi-agent to have an effective and efficient way of fabrication. The major elements in such a system are the human-machine interface, communications network, and the intelligent machine agents. Process quality is a top-level concern which continuously advances through monitoring and adoption of technological improvement. Development of manufacturing plan and top-level conceptual designs are also good ways to start manufacturing modernization. Adopting a multi-agent cooperative and communication network infrastructure provides the foundation for integrating the manufacturing system. Lastly, designing, developing, and integrating workstations along with monitoring and adopting new technology that fits the strategic plan can be considered to serve the purpose to modernize manufacturing in the future. Planning of automation and robotics and their future should have an understandable image of the purpose, which is determined by the tools discussed above or outlined below. Intelligent smart automation, embedded sensors in products and processes, reconfigurable robotics, human-robot collaboration, wireless real-time sensing, networked control for telerobotic and remote operations, using robotics to substitute or complement human labor in new ways. In this slide, we're going to discuss about technical and ethical issues. Robots are not fully autonomous and therefore require supervision all the time. Robots should be made in a way that they do not harm the user or the environment. Lastly, workers in factories are being continually replaced by high production robots, thus increasing the unemployment rate.
Recommendations. The first recommendation is regarding the safety. The sensors can be made or improved to detect human presence in a factory so that the sensors restrict and or minimize the amount of work that the robot does, which can compromise the safety of the people present in the vicinity of the robot. The second one is building the robots so that they are able to adapt to any work conditions. A robot used to cut a workpiece can be used to drill and weld too. Multifunctional robots can be used to minimize the cost, time, and space needed for manufacturing. Conclusion. The advanced robot technology for manufacturing was invented to further help humans develop better and faster ways to manufacture. Robots excel in doing simple, repetitive tasks very accurately and in less time compared to a human. Now they have become an integral part of manufacturing in high production facilities. The robot technology is now evolving from just doing simple repetitive tasks to more complex repetitive tasks. There will be more advancements in the future of manufacturing, as the humans find better and more innovative ways to make robots. The automation of robots will soon be without much of human interaction. The evolving advanced robots will soon replace most of the laborers in manufacturing industries and lead to a much safer environment.
So this is the end of our presentation. Thank you for your time and consideration.